Welcome back, everyone. Once again, this is Ray Aslin. I'm a technical trainer for Fortinet. I teach the public cloud security course. And if you're listening to this video is for lab number 6 with AWS. And as I have said at the beginning of several of these other videos, we have previous videos that I hope that you've watched before you do the lab number 6 video. The very first video we did was lab number 1 and lab number 2. We deployed a FortiGate in a very basic configuration, and then we used the Fabric connector to create a dynamic address object. In lab number 3, we deployed a FortiWeb. In lab number 4, we did a FortiGate HA pair, a active-passive HA pair using FortiGate clustering protocol. In lab number 5, we deployed a load balancer in front of, well, ordinarily what would be 2 standalone FortiGates, but in our case, we used 1 standalone FortiGate, and then we repurposed the HA pair as another standalone FortiGate. But we were doing active-active by using a load balancer in front of our FortiGates. Lab number 6 is going to take that concept that we learned in lab 5 and take it just a bit further. Let me pull up this diagram and we'll talk about what we're going to do in lab 6. In lab 6, we're going to use the auto scale function. And when I say the auto scale function, let's actually be a little bit clear here because this can get a little confusing. There are 2 things that are known as auto scale, and they do relate with each other. One of them is the functionality of the cloud provider. The functionality of the cloud provider to be able to scale out a set of EC2 instances and add more EC2 instances when load is high, which is typically measured in CPU utilization. As you can imagine, if we have more traffic flowing through the FortiGates, CPU utilization goes up. As we have less traffic going through the FortiGates, CPU utilization goes down. So the cloud provider can monitor CPU utilization and add more FortiGates, and then remove FortiGates when load is down. Likewise, the cloud provider could do this for web servers and database servers and really any type of EC2 instance that you could probably come up with. We could scale out and scale in. And that's the cloud provider's auto scale functionality. AWS calls that an auto scaling group. The group of EC2 instances an auto scaling group. Now, the other thing that's called auto scale directly relates to that is a feature in FortiOS called auto scale. And the feature in FortiOS called auto scale exists largely to support the feature in the cloud service provider. If you can imagine, I had a group of EC2 instances that are FortiGates. Let's just choose a pen color here. We'll go with blue, sure. So I've got this group of FortiGates. Well, that didn't work right. Let's try that again. Pen, there we go. I've got this group of FortiGates right here. And CPU utilization averages higher than the threshold for, I believe the default is 5 minutes, and it scales out. And adds another FortiGate, and it scales out again, and it adds another FortiGate. Oops, there we go. So these 2 little blue boxes are more FortiGate EC2 instances. Well, when these instances boot up, they're going to need to have firewall policies that match the existing FortiGate instances. You know, a FortiGate is only particularly useful if it has the correct firewall policy on it, if it has the correct firewall policies and the objects to support those firewall policies. So there is a feature in the FortiOS that synchronizes configuration, and it's called the auto scale feature. I believe the CLI for it is config system auto scale. If I have that slightly wrong, don't worry, we'll see it come up in the lab, but that sounds about right. Config system auto scale is where the CLI is for that. And basically what happens within this feature is we identify a master FortiGate, and that's where we configure things like policies and objects. Let's turn that into P. And then those policies and objects on the master FortiGate are synchronized to the other FortiGates. The other FortiGates and their config system auto scale command line interface in their settings, they identify the master by its IP address. There is a pre-shared key, a secret that has to be in sync between all of these guys, basically a password that has to be in sync between all of them. And if the password is in sync and the master is correctly configured, they will learn new policies and objects from the master. So when one of these new virtual machines, these new EC2 instances boot up, it'll initially have just the configuration to identify who the master is. That configuration is going to get bootstrapped into the FortiGate. It'll be a configuration that's held in the S3 bucket, very similar to what we saw in the active-active HA that we configured. Oh, pardon me. That was in the active-passive HA, that we configured a little bit earlier. So they'll have IP addresses. Initially, they will have the the auto scale functionality configured to point to master, and then they will learn all the policies and objects after that. And then they'll go into production and start load balancing traffic. So let's take off the ink here and talk about what else we needed to make this work. There we are. So this auto scaling group functionality within AWS, that includes these EC2 instances, that's the functionality that allows you to scale out and scale back in. In order for this to work, there's an AWS Lambda that is running that actually executes and does the scale out and the scale in. There's information about this set of EC2 instances that's recorded in a Dynamo database. There's also an S3 bucket. The S3 bucket is used for the deployment of these. We actually deploy this with a CloudFormation template. Also, things like bootstrapped configuration is stored in that S3 bucket. So that's used for a couple of different things. Now, as you can imagine, we're trying to support typically an application inside of the VPC, and we are auto scaling out and auto scaling in so that traffic can go to that application. In this particular diagram, this application is a group of web servers. So I see this group of web servers down here. This is probably in its own auto scale group. If we consider the fact that we're needing to spread traffic between multiple FortiGates because utilization is going up, we probably also need to spread traffic to more web servers because utilization is going up of our website. That's probably why utilization is going up of the FortiGate. People are hitting our website. So we're going to need to use some load balancers. When you use auto scale groups, you're going to use some load balancers. First, we have an external load balancer. An external load balancer is a load balancer where the listener is publicly accessible, either through a DNS name or through perhaps an elastic IP address directly, but probably that elastic IP address is DNS resolvable, so it's about the same thing there. But folks will hit that elastic IP or that DNS on a particular port configured on the listener. Let's say that it's port 80. And then the load balancer, instead of load balancing to a target of FortiGate instances or the IP address of FortiGate instances, the target is the auto scaling group, which means as more FortiGates get added as we scale out, those new FortiGates are included as targets. And likewise, as we scale in, because utilization goes down, let's say that we scale in and this FortiGate gets removed and this FortiGate gets removed, then we're no longer load balancing to those FortiGates. Within those FortiGates, within the FortiOS, we're going to configure VIPs, and those VIPs will be added to firewall policy, and those VIPs will allow access to our internal application, the application that's on a private subnet that we want to flow through the FortiGates. The mapped IP address of the VIP will be an IP address of an internal load balancer. So we have another elastic load balancer here that's an internal load balancer. What's the difference between an internal load balancer and an external load balancer? Really, the difference is what the listener is. In this case, the listener will be a private IP address or an IP address of something within our VPC. So the VIPs will point at that, and let's go ahead and change our color here. We'll put in purple. I like purple. So our VIPs will point at this. Even as more FortiGates get added, their VIPs get synchronized by the auto scale FortiOS functionality, and they will load balance to probably a set of web servers in their own auto scale group. If they're not in their own auto scale group, this still works fine. It just means that your web servers aren't auto scaling out and auto scaling in, which might mean that you've scaled out all the FortiGates that you need, but you might need to scale out more web servers. So it's probably an auto scale group for those web servers. That certainly makes the most sense. So there's some other things that we need to be concerned about here. When we talk about the FortiOS auto scale functionality, one of these FortiGates will be identified as master. Let's put put a circle around the master pen, and we'll do this in black ink. Here we go. Let's say this one's the master. Well, we need to make sure that the master isn't shut down, terminated. We don't want somebody to come in and delete the master. We also want to make sure that the scale in process never scales in and removes the master. So there's a couple of extra settings that we'll use here. For the instance setting, we'll enable termination protection, which keeps the instance from being terminated, from being deleted. For the auto scaling group functionality, we will set something called scale in protection so that FortiGate is never removed as part of a scale in option. We can also do other things like set the minimum number of size in the scale group. So if we want high availability as well as this ability to scale out, it makes sense to set the scale in to a minimum of 2. That way, if there's some type of OS failure that causes the OS to reboot, we still have another active FortiGate that we can load balance to. We can also set it higher than that. We could set it down to 1. I don't think we probably want to most of the time because we do want that high availability, but we certainly could do it. We can also set the maximum size for the scale out. That way we don't have some type of phenomena happen where CPU utilization is unusually high, we have a bunch of traffic, but we've scaled out and increased our billing to a degree that we can't tolerate. We're going to pay more for this than we wanted to because it's scaled out and included, I don't know, 10, 15, 20 FortiGates. So there's a maximum size that you can set, a minimum size that you can set, a desired size that you can set. The desired size is just the number that it's going to deploy when it initially deploys. So if we set the desired size to 3, it's going to deploy 3. If we set the minimum size to 2, 5 minutes later, it might reduce that 3 down to 2. So think about that desired size as just the initial deployment, and then we use the thresholds, the CPU thresholds, to either scale out or scale in. And that happens automatically. The monitoring of those thresholds is happening within AWS by the auto scaling group functionality. The Lambda is executing, scaling out, scaling back in. All of that information is being collected for us. We're really just deploying all of these various pieces. So there is one other element of this diagram I think I haven't talked about yet. It is similar, I believe, to what we did in Lab 5. Yep, it is similar to what we did in Lab 5. Because we want this to not only be scalable and auto-scaling, but we want it to be highly available, it makes sense to spread this to multiple availability zones within a region. That way an availability zone failure doesn't affect our application, or it doesn't completely take down our application. It would just take down the instances within that availability zone. So what we're going to do is have 2 sets of subnets. We'll have a set of subnets in what they identify as availability zone 2, and I've been using US East 2, or the Ohio region, and I'll probably use AZB for that, or AZ2 for that, and then I'll use, for this other availability zone, I'll use AZ1. As subnets cannot extend in AWS beyond availability zones, we're going to have a couple of different CIDRs for our public subnets and our private subnets. So on public-private in AZ1, we'll have 10.0.0/24, and then on private, 10.0.1/24. We've been using those for publics and privates in several different labs. Those CIDRs should sound pretty familiar. And then we will also have a public in the other availability zone and a private in the other availability zone. And that'll be 10.02/24 and 10.03/24. So for the third octet, right, 0 and 1 are in one availability zone, and 2 and 3 are in another availability zone, 10.030/24. All of them, of course, within the VPC of 10.0/16. In the last CloudFormation template we deployed, we used a template that used the existing VPC. This template's going to be different. I'm going to deploy a template that deploys our VPC for us. All of this should get created for us. Okay, I think that's probably enough information to get started. As you guys have probably learned from my style of doing these videos, I'll probably go back and forth to this diagram a couple of times. I'm a visual learner. I appreciate having a diagram, so I like to refer back to it because I think other folks feel the same way. It's nice to have a picture of what's going on. Every once in a while, I meet somebody who doesn't need pictures at all, and I'm always impressed with their ability to learn information without looking at a diagram. So if that's you, you have impressed me. I need a diagram. I need pictures. So let's go get some files. The first thing that we're going to need is we're going to need our CloudFormation template. This is going to work a little bit differently than the earlier CloudFormation template. In the earlier CloudFormation template, I just needed a single JSON file. That file had all of the different templated information that I need. This is going to be a bit different. This template has links to other templates. So what I need is a zip file package from GitHub, and I need to unzip that package and upload it in its existing file structure into an S3 bucket. I need all of it to get uploaded in its exact structure, and in the template deployment, I will specify what the S3 bucket is that it's listed in, and if I put it into a subfolder, which I am, I'm going to put it in a subfolder, I need to tell it exactly which subfolder the unzipped package is in so that it knows where to find all of those files. The deployment is going to look for files and look for information in very specific places. Let's go to github.com, hub.com/Fortinet. I'm actually going to go ahead and go to, I think it's under auto scale. If I get this wrong, I'll look for it here in a second. Releases, that sounds maybe slightly incorrect. Let's see. Nope, GitHub page not found. That my memory is a little bit off there. So let's go, you know what? It's not auto-scale, it's FortiGate-auto scale. That's what it is. Let's go over here and say /Fortinet/FortiGate auto scale releases. As you can see, we have multiple releases of the packages. I was using 2.07 for quite a long time. It worked really well. 2.8 has more recently come out. I'm going to go ahead and use 2.0.8. And the file that I want is the FortiGate autoscale AWS CloudFormation.zip file. And I'll go ahead and click that and download it, although I think I downloaded this yesterday as well. Let me pull over. Yes, I downloaded the same file yesterday. So I'm just going to reuse, rather than go digging through my downloads folder and getting it, I'm going to use it. It's right here. FortiGate, Autoscale, AWS, CloudFormation. I've placed it in its own subfolder so we don't have to muck through all of my other things. Here we go. Muck, technical term. Muck through. As I'm waiting for Windows to, thank you, Windows, to allow me to click the Extract All button, I'll tell you where I learned the word muck and why I relate it to digging through files. Extract All. So in my spare time, I'm a scuba diver. I love to scuba dive. And there's this type of scuba diving called muck diving, where you dive through water with very low visibility, usually like really dirty on the bottom, and you try to dig through that muck and look through that muck and find really interesting things, really interesting fish and life and things like that. It's called muck diving. So that's why I use the word muck for looking through a bunch of files, trying to find a particular file. See, users are Aslan. Yep, let's just extract it right there. Give it a moment. Windows acts like it's working really hard to unzip a relatively small file. Thank you, Windows. Indeed. All right, so this is the unzipped folder structure. This is what I'm going to upload into my S3 bucket, and I'm going to upload it into the exact same file structure. I will create a subfolder for it, and then later during the deployment process, I will have to specify the name of the S3 bucket that I uploaded it into and the name of the subfolder within that bucket that I placed it in. So let's hold on to this. We'll need it shortly. Let's go back over to AWS console. I'm already in the S3 screen, but let's just clarify how I can get there. Underneath services, if you've visited these services recently, they'll be in your history on the left side. Otherwise, you can go under storage, you can go to S3. If you've watched Lab 4, if you've watched Lab 4, you saw how to create an S3 bucket before. However, I'm going to create an S3 bucket again. I deleted that bucket a couple of days ago now. Let's create a new bucket. I want my bucket to have a unique name. So let's give it something like FortiGate autoscale. Let's get the mouse out of the way. Dash Lab 6. Because this is for Lab 6. Today is September the 10th, so I'll say 09/10/2020. S3 buckets have to be unique named between other customers. So I'm just basically giving this a name that's very unlikely. Here, we'll just add one more thing, R. Aslan. My first initial and last name, very unlikely to have been used by any other customers. And if it has, if it's used, it'll give me an error and that'll be fine. Copy said, no, I don't have any other buckets. And I believe I can just take the defaults here. Block all public access. Yeah, that's the part that I wanted. I don't want to have public access to this. I want to have access to it programmatically. The other portions of AWS that I use in this configuration will have access to it, but the general public doesn't need access. There's a lot of things you can do with S3 buckets where the public might have access, or at least have read access into it. Let's go ahead and create our bucket. Oh, I should have mentioned before I did this, there are two versions of the S3 console. So if you log into the S3 console, it doesn't look exactly like this. You might, here we go, switch to the new console. It might look more like, I'll click this, switch to the console and wait for AWS to catch up with me here. It might look like this. Honestly, the difference in the GUI is in the wizard that I just went to create that is it's pretty minor. Basically, you give a bucket a name and you really just take the defaults beyond that. All right, let's click on, I'll go ahead and stick to this other console. Pretty sure it's the same after this screen anyway. There we go. Now with clicked on the bucket, I want to be inside of the bucket. I'm going to then create a folder within my bucket. So now I am within the FortiGate Autoscale Lab 6 bucket that I created. Let's create a folder. I'm going to call the folder deployment package-package. Here we go. I'm not going to use any kind of encryption on that. Let's save that. Now I'll click on the folder and I'm ready to upload some files. Let's click the upload button and drag and drop some files in here. So let's highlight all of these and we'll just drag them and drop them. All right, very good. I see my package.json, README, templates, assets, functions. Yep, very good. The initial template file is actually the Bob Cloak's turned on in this bucket for granting public access. Yep, I'm okay with that. I don't want to grant any public access. It's really just me. And let's say next. What kind of storage class do I want to use? This really just depends upon how I get charged fees. The standard storage class is more than sufficient for what I need. And we will upload. It's only about a 1 meg upload, so this isn't going to cost me a bunch of money. Relative to some of the other things that we've done, this is probably one of the least expensive services that I could have used. By the way, in case you are following along, if you are really careful and you create these objects and then delete them all when you're done, you can do all 6 of these labs for about $10 US if you do them all in the same day in about an 8-hour period and just run straight through them and delete everything as soon as you're done. You don't let anything run any longer than that. I can usually do all of the labs for less than $10 US. To make this set of videos, I've run them over a number of days. And as you can imagine, there's doing the lab and then there's reading it aloud as you go and walking through it, and that always takes a little bit more effort. And I think I'm up to $15. And I've run this over multiple days, although I do delete everything at the end of the day. But I'm going through it much slower than you probably would just doing the labs yourselves. I know it doesn't feel like that. Like in the video, you're thinking, oh, you went right through it. Sometimes I do things 2 or 3 times so that during the video I have a nice smooth experience. And even with that, doing it a couple of things a couple of times, still only $15 US. But as much as possible, if you're going to go through these, I advise you to very carefully go through them quickly, delete as soon as you're done, just to keep your billing down. Once you've seen it only bill at $10 US, if you want to try it again, you can always try it again. All right, well, as you can see, our files have uploaded into the bucket. Now we need to go and find a particular template file. So we'll go to the templates folder. And let's just look for all of the files in here that start with the word auto scale. That should cut down the list pretty. There we go. And I believe this is the one that I want. Auto scale new VPC template. So what we have is a single template file called autoscale new VPC template that's going to call other files during the actual CloudFormation deployment process. So I'm going to need this file's URL, and then I'm going to need the name of the bucket that it's within and the name of the folder that I created. All of those things will go into the CloudFormation template so that it knows where this specific file is, which starts the process, and then it knows where to find other files and folders within this structure. Let's see, as I go over here, if I click on this, will it, yeah, let's give it, there we go. So just, let me just go back quick, show you what I did, because I did it kind of quickly. Let's go over here and say auto scale. And there's the new VPC template, auto scale new VPC. It's going to create a VPC for me. Well, the first time I clicked on that, it actually had a little call out on the right side that had this information in it. And then when I clicked on that call out, it actually made it full screen. And that just makes it a little bit easier for me to read. So I'm going to need Notepad because I want to note a few things. Let's pull Notepad over here. The first thing that I need is the object URL, basically the URL location of that specific file. Let's just do copy and paste that in there. That will be the location of the template when I start the CloudFormation template deployment process. I'm also going to need the name of the S3 bucket, which is embedded within the actual URL, right? That's the name of the S3 bucket right there. However, I'll just grab it here and FortiGate-autoscale-lab6.09102020-R aslet. Very good. And the name of the subfolder that I put the unzipped deployment package in. So we'll come back to this. And when I do this, I will need to put a trailing / on the end because it's everything that it needs is located underneath that folder. So I'll go ahead and put the trailing / in right now. By the way, that's a pretty easy mistake to make. So when you're following along, I would watch the whole video and you can see where this is going to go, and then you can go back and do this, but look out for that trailing / It's a really easy mistake to make, not putting that in there. So we've got all of those things. Now we can go and start our template deployment. So we'll just pull this over to the other screen for a moment. We'll go to services, and I'll go there the most manual way. You might have a CloudFormation shortcut underneath your history if you've been doing other labs. Otherwise, go down to management and governance, go down to CloudFormation. My earlier stack was deleted. The stack that I created for high availability, active passive high availability earlier was deleted. When I deleted it, it rolled back all of the objects. And so when I come to this screen, there's no existing stacks in the list. I can go over here on the left side. Actually, there was a little 3-line menu icon. I can go to that 3-line menu icon. I can click on stacks. There's no other stacks. So I could have clicked create stack from that other screen. I could click create stack here. It's both going to take me to the same place. So let's say that the template is ready. it's going to ask me, where is the template? Now, previously I uploaded a template file and it actually created an S3 bucket for me when I did this before. Here I have a bucket and it has many files in it. So let's just point to the existing bucket. Let's go back to Notepad. And this is my object URL. Oop, I don't want all of it. I just want the first line. Here we go. Control C and Control V. Very good. Next. Let's try it again. Next. Very good. Similar to our previous lab when we did high availability, it's going to ask me for a number of parameters. We're going to give it, our stack gets a name. Your stack always gets a name. Fortinet, FortiGate. When we create resources, resources can be tagged. That can be useful later for any number of purposes. Tags they're just extra bits of data about the resource. The name, when we've been creating EC2 instances and VPC, the name is just another tag. Because as we've learned by now, every resource, every object that we create has an object identifier or resource identifier, like EC dash a string of alphanumeric characters, or VPC dash a string of alphanumeric characters. Elastic IPs, everything gets a resource identifier. So what we're creating is a tag that has an identifier that says it's part of this. So FGT ASG, that's FortiGate Autoscaling Group. That'll be the resource tag, and then the resource name prefix. I'm going to go with FGT ASG as well. So within the name of the resources that are created, they will get this prefix within them. So next, it's going to ask me some questions about where I want to deploy. This is going into US East 2, Ohio. So I'm going to choose 2A and 2B. There we go, 2A, 2B, very good. I'm not going to use the default VPC CIDR that comes with the template. We've been using the 10.0/16 for everything else, so we're going to stick with that. So let's just say the overall VPC CIDR is 10.0/16. And autoscale subnet 1. So let's talk about that. They say autoscale. These are your public subnets. So this is public subnet 1, public subnet 2. So if you recall, our public subnets were 10.0.0.0/24 and 10.0.2.0/24. Those were public 1 and public 2. And then our protected subnet, those are our private subnets. That's going to be 10.0.1.0/24 and 10.0.2.0/24. By the way, I'll go back to the lab diagram before we're all done and make sure that I'm typing these in correctly, because you never know. Oh, you look at what I did there. In fact, I tried to make a mistake already. This is supposed to be 10.0.3.0/24. I guess after typing in .1, my brain just went, well, 2 always goes after 1, so let's put in 2. There we go, 10.0.30/24. So 0, here we go. 10.00, 10.02, those are my 2 public subnets, 1 in each availability zone. 10.01, 10.03, those are my 2 private subnets, 1 in each availability zone. Now it wants to know how large of a VM I need to create. In high availability, when we did active passive, we needed a total of 4 interfaces on the FortiGate. We needed a public interface, a private interface, a management interface, and a sync interface. And remember, the sync interface is where the heartbeat and synchronization traffic happens. The management interface is where API calls are made for a failover event. Here we don't have active passive failover with the API calls, so we don't need the management interface. We can manage the FortiGate on its public side interface. Each FortiGate can get a public IP address that we can use to reach it for management purposes. It will also be load balanced with an elastic IP, but each one will get their own public IP. So we can manage it through that. The sync interface doesn't need to be there. We can sync through the auto-scaling sync functionality can happen through the private side subnet. It can happen through the public side subnet. It doesn't need a dedicated subnet because there's not a heartbeat that's happening. We don't have to go into HA and configure that. So I only really need 2 different interfaces. Since I only need 2 different interfaces, I don't need an instance this large. So I'll stick with T2 small. It'll cut down the cost of my lab. 623, it's the only FortiOS version that's specified in this template. And by the way, as templates get updated, they commonly include newer versions of FortiOS, and sometimes they don't include older versions of the FortiOS. Just a little tip. If you don't want to have to customize some template that you download later, if you find a template that you're deploying that you like, and you might save that template, sometimes a new template will come out and it'll have an option that you don't want, and then you'd have to go and customize the template so it offers you a different option, like what version of FortiOS. I'll go with 623. It's the only option in the list. But if, for instance, if we go looking in my folders on my Windows PC, I used to use the 207 for quite a long time. And when 208 came out, I wasn't sure if I was going to like the way it worked for class labs, so I always kept the 207 out there. This is only, I think, the second or third time I've used 208. And it's just some minor fixes. I don't think I've even seen a difference. Okay, FortiGate pre-shared key secret. This is going to be a secret that is used for the auto scale functionality. It'll be set on the master, and it'll be set on everyone else who syncs from master. They have to have a pre-shared key that's in sync that matches in order for that auto scale to work. As you can imagine, we don't want some FortiGate popping up in there that doesn't know the pre-shared key secret and getting all the policies and objects synced to it. So I'm just going to make this nice and simple. NSE7 cloud sec. I'm going to jot down what I'm setting it to just in case I need to troubleshoot something later. That's what I'm setting it to right there. Control C, and I'll actually delete that and put it in there. Exactly. I mentioned that each one of these FortiGates is going to get a public IP address on its public side interface. It won't be an elastic IP, so it'll be very similar to the standalone FortiGate that we created earlier. It'll be one of those dynamic public IPs. It's not an elastic IP. And we can use that to be able to manage and monitor each of the FortiGates. We will manage them on port 8443. Why not port 443? Why not port 443? Well, the reason that we're avoiding port 443 is there might be a VIP that's listening on port 443 because we might be load balancing an SSL application. In fact, I would say if we're load balancing a web app, an HTTPS app or a TLS app is quite likely what we're load balancing. So that's why we're going to move administration or management over to port 8443. Next, it wants to know which source IP addresses are allowed to administer this, and I'm just going to stick with 0000/0. I have a dynamic public IP address for my ISP, so I don't want to specify a specific public IP. Key pair name, I'm going to use the lab key pair that we created earlier. Now we get into autoscale group configuration. There's 2 sets of autoscale group configuration. There's bring your own license images. How many bring your own license FortiGates should I deploy? And how many pay-as-you-go FortiGates I should deploy? First of all, a little note about bring your own license. Yes, this template does support bring your own license FortiGates. So yay, it supports that. If you're going to do that, you'll need to upload your license files into that S3 bucket in a pretty specific directory. Let's see if I can pull up maybe the cookbook for this and see if I can find the directory, because I believe it's supposed to go in a very specific place within that directory structure. That way, as new FortiGates scale out, it grabs the licenses. As they scale back in, the licenses are not used anymore. But I'm not going to use any bring your own license. So I'm going to set the desired capacity for BYOL to 0, the desired capacity minimum group to BYOL to 0, the maximum group BYOL to 0. Yep, all of that. The desired capacity, I'll set that to 2, and I'll set the minimum group to 2, and I'll set the maximum group to, I'll set it to 4, but it really shouldn't need 4 at any point during my lab deployment. Good. Scale out threshold, this is about percentage of instance CPU utilization. It has an 80%, if it hits 80% utilization, and I believe it's a 5-minute timer or a 5-minute average, then it scales out. It has a 25% scale in. If it averages 25% for 5 minutes, it scales in. There is a 5-minute master election process, a 10-minute process for it to get the license if you're doing BYOL. That's not used for pay-as-you-go. Health check, grace period, length of time in seconds that autoscale waits before checking an instance health status. So as you can imagine, when an instance first boots up, its health is not, it's had to initialize for a couple of minutes. It's got to boot the OS, bring it up. So we don't even check the health status on it for the first 5 minutes. It has to sync its policies for its VIP. So all of that needs to be able to wait 5 minutes. We'll just go with the defaults. What do we want to load balance? Well, we're not going to do an HTTPS app in here, so we'll just do load balance HTTP. We'll change the traffic port to port 80. We'll add a new internal load balancer. So recall the internal load balancer is going to be the mapped internal IP address for the VIP. I don't have an existing internal load balancer. If I already had my app deployed, I might already have an internal load balancer. So I could say, oh, use a load balancer specified below. I already have it. And you can see the internal load balancer's name. I could specify it down here. I don't. If I didn't think I needed one, I could say I don't need one. I'll just let it create the load balancer for me. And it's asking, well, what do you want the internal load balancer's DNS name to be? If we're going to add one, let's call it FortiGate ELB. Now we could configure things like heartbeat loss, heartbeat delay. This is all based on the autoscale handler understanding that an instance is still there, that it's still responding. So if an instance went down, we're checking every 30 seconds. If it misses 3 consecutive attempts, it's considered down. At that point, we might scale out to add another one. The heartbeat delay, maximum amount of time allowed for network latency of the FortiGate heartbeat arriving, minimum is 0. Shouldn't be very much delay in there. Okay, last thing it's going to ask me that I need to put something in for is the name of the S3 bucket that all of our package was unzipped into and the name of the folder that everything was placed in. So I'm going to go ahead and grab this. Control C, it was placed in here. And right here, the name of my bucket. Now my memory is kind of tickling me a little bit, and my memory is telling me that if I do have bring your own license files, I think they might need to go right within that deployment package folder. But I'm going to go ahead, since my memory is tickling me a little bit here and telling me that that might be correct, I'm going to go ahead and pause the video for just a minute and go double check myself. Because I'd like to be able to, since I'm thinking about it, I'd like to go ahead and remember to tell you that and be able to tell you that right now. So I'm going to pause the video for a moment. I'll be right back. Well, that took me at least 3 or 4 minutes. I actually didn't really look how close at the time. I'm sure you can look at the corner of my clock and figure out how many minutes it took me. But I did find it finally in the cookbook for deploying autoscaling on AWS, where they cover the placement of the deployment package within an S3 bucket, basically going through some of the same things we just went through. It looks like underneath the assets folder, you will upload, if you are using bring your own license instances, navigate to the assets folder, create a folder named FGTASG license right there with those hyphens, upload your FortiGate licenses to that folder. So it is not directly underneath deployment packages, it's underneath deployment package, assets, underneath that, create a new file. And this was available in the FortiGate FortiOS 6.2 AWS cookbook. It's under the deploying autoscaling on AWS. And underneath that, there's 2 ways that we could do this. Deploying it without transit gateway, which is what we happen to be working on now, and within the obtaining the deployment package, which is a funny place to put it, by the way. But there it was in very small print. I found it right there. All right, very good. Let's go ahead and close off all of these windows that I was scouring through, that I was mucking through, if you will. If you remember that from the earlier part of the video, that's now an inside joke. So if you ever run into me at an event, just ask me if I've been mucking through anything lately, and I will probably have forgotten this video. So then remind me it was the public cloud video. All right, very good. So we have the name of our S3 bucket, we have the deployment package, and if you forget about the / thing, if you just read it must end with a /. They do remind you of this, but boy, let me tell you how many times I haven't put that / in there, even though they tell me to put it there. Very good, let's click next. I'm gonna take the defaults here, the stack policy for rollback configuration. Oh, there we go. There we go, the stack creation options, that's what I was looking for. If this stack fails to create, it's gonna roll back everything that it created. If it got halfway through the creation process, it's supposed to roll back everything. That being said, I will tell you, if it failed to create, I would still go looking in EC2 instances. I would still go looking through all of it to make sure it deleted everything. It's because I'm not that trusting, I suppose. All right, very good, let's go ahead and click next. There's gonna be some agreements that I have to make near the bottom. Here we go. I acknowledge that this might create some identity access management resources. Indeed, it might give my virtual machines or different types of resources permissions to do things like add more FortiGates in an autoscale group. And I acknowledge that it's going to require the following capability: auto expand. That one's really about letting me know that with the auto expand capability, there may be a cost deploying this template, and that cost may increase later because it's adding more resources as it auto scales out. Right, I feel pretty comfortable with all that. I could scroll up and look through all of my various settings. I'm going to hope that I did things right. I'm not going to go and look through that, and if it fails, well, that'll serve me right for not checking. Let's go ahead and click Create Stack. Very good. This is going to execute some other templates. So the first template's going to execute other templates. As I refresh, we should see several create processes get started by this. I could look at nested, I could turn this on, and indeed there's going to be lots of nested stacks deployed. So there's a sub template that's used here, or a nested template that creates the new VPC. If I continue to refresh, there's just going to be more and more of these. Once everything is complete, the initial stack that I listed, the Fortinet FortiGate stack, that was the name that I gave it, should show a completion here. The print should show up in green. That's going to take a few minutes. If you're doing this on your own, I would say expect anywhere from 5 to 10 minutes to be pretty typical. And since it doesn't make sense to sit here and record for the next 5 or 10 minutes, I'm going to go ahead and pause the video and go fill up my cup of coffee, come back, and hopefully this will be ready to go. So everybody, good time to take a break. Feel free to pause your videos, and we'll be back in a few minutes. Well, very good. It has been more than a few minutes. This template deployment probably finished in about 10 minutes or so, and then I took care of a couple of things. So it's probably been about 15 or 18 minutes since I kicked this off. I doubt that yours will take that long. Over on the left side, it says create complete. I can refresh that. There, it says create complete. Over on the right side, it says new events are available. If I refresh this, there's going to be a list of sub events that got kicked off. And yeah, there we go. And if I did view nested on the left, you'll see there's a lot of things that actually got kicked off. That's fine. That looks to me like everything was deployed. So what I'd like to do is take a moment and revisit our lab diagram. So I think I mentioned that we would revisit that earlier. So during the template deployment, we listed some subnets. Let's add a pen here, and we'll go in black. The autoscale 1 subnet and the autoscale 2 subnet were these two subnets. And pen, there we go. That one and that one. And then the protected subnets or what I refer to as the private subnets, where these two subnets, 10.0.10, 10.0.30. That should have been what I put in there. Hopefully that's what I put in there. We'll see very shortly. It created this load balancer for me. It created this load balancer for me. It created an auto scaling group that included those two FortiGates. Also created Lambdas and DynamoDBs, and we'll actually visit this Dynamo database here in a second. We'll pull up a table and we'll find out who the master was, the autoscale master, because we're going to do our initial configuration against that, and we're going to make sure that it doesn't get terminated on accident. We're going to make sure that it doesn't get scaled in by the auto-scaling functionality. So we will go and visit that database very shortly. So these are the things that were deployed, and we did this in availability zone A and availability zone B. So these are the two things that we had deployed. Let's erase our ink there and just go back to a normal mouse clicker, pull this over. Let's go visit that and make sure that that's what it looks like actually happened. So let's go visit the network first. We'll go to VPC. Indeed, I only have one VPC, right? I have 4 subnets. Let's go look at my subnets. Now, we've got that name prefix in there, FGT ASG. I see autoscale public subnet 1, public subnet 2. Let's move this availability zone a little closer here, be a little bit easier to see. Yeah, public subnet 1, public subnet 2 is US East 2A, US East 2B. Indeed, A and B were the two availability zones we used. And then we have private subnet 1, private subnet 2 there, and indeed, private subnet 1 is in US East 2A, private subnet 2 is in US East 2B. If we look at the CIDRs match what we expected, right? All of the subnet 1s, all of the AZAs are 10.0.0/24, 10.0.1/24. The stuff in availability zone B is 10.0.2/24, 10.0.3/24. That looks right. We should also see some EC2 instances. Let's go look at our EC2 instances. We've got 2 running instances. Let's go have a look at that. I see an instance that's shutting down. Makes me wonder if I might have made a mistake during my template deployment. I wonder if I set desired instances to 3. If I did set desired instances to 3, it would have deployed 3. If I set my minimum instances to 2, after 5 minutes, it would have terminated one of them. So I might have made a little mistake because I see 3 instances here. Let's just go check out my mistake. Let's see if I really did make that mistake. So what I can do is go back to my CloudFormation template, go look at my stacks. There's my stack. Let's click on the stack name. I should be able to go back to parameters on the right side and go look at the pay-as-you-go option. FortiGate max size, bring your own license. Here we go, desired 2. Maximum size 4, minimum size 2. Well, perhaps because I did a T2 small instance, that's 1 CPU, 2 gigs of RAM, I believe. Perhaps it, during the deployment process, as it was going through reboots, maybe it deployed and needed a 3rd one for a very short time, and then later did not need it. Because as I'm looking, my settings appear to be right. Minimum size is 2, maximum size is 4, desired capacity is 2. So it must have had a scale out. We'll have to check that out when we're done. We'll see maybe if we can find out why it had that scale out event. suspect that I had some high CPU utilization. So this is what I get, I suppose, for letting it sit there for an extra 7 or 8 minutes. 5 minutes of average use went by, and I guess I hit a threshold. We'll check that out here shortly. Let's go see who the master is that was deployed, because I have these two instances. What I'll do is I'm going to go ahead and close that other window, that other tab. Actually, that's not what I wanted. I wanted to duplicate this tab. This way I can go look at two different parts of the AWS console at once. So over here I have my list of instances, 1, 2, 3 instances. One of them is terminated. So I have one instance in 2A, one instance in 2B, so one in each availability zone. If I look at my instance identifiers, let's make this a little wider so we can see the full numbers. There we go. One of them ends in 126B, the other one ends in alpha or 6 alpha 33. So one of those two, hopefully one of those two, is my master. So let's come back and go to DynamoDB. It's in my history list because I've done this lab recently. Let's go to where I would get to it if it wasn't in my history list. Underneath database, second item down, Dynamo database. It's basically a simple database service that just lets you create tables and fields in the table. It's like a NoSQL database, something along those lines. All right, we'll go down to tables. And I see license you to get auto scale and master election. Name of a table, and then there should be an item in there, and the item should describe the instance ID of the master. The master is currently 126B, the instance that ends in 126B. So this is what we will go do next. We will go find 126B, we will edit it, we'll call it the master or FortiGate master. That way we know which one it is. Then we'll go into our instance settings and change the termination protection so that I don't accidentally terminate this instance later. Now that'll keep me from going in and, well, actually, let's just do it. Instance state, terminate. Are you sure you want to terminate these instances? These instances have termination protection and will not be terminated. Use the termination protection option from the instance screen action to allow these to terminate. So basically this is saying, you can't click here, Ray. You told me not to let you do this, and it's not letting me do it. So if I wanted to be able to terminate that instance, I'd have to go turn off the instance termination protection that I turned on just a moment ago. As opposed to this, where I could say instance state, terminate, and you'll notice that the blue yes terminate button is lit up, it's highlighted. I could click on it. I don't want to, so I'm gonna go ahead and hit cancel, but it's there, I can do that. Since we're on this screen, I'm going to do something else as well. There's a public IP address that's assigned to that instance. Notice, similar to something we discussed in Lab 5, this is not an elastic public IP, it's a dynamic public IP. I'm generally okay with this though. In an elastic IP, a lot of times we want the IP to be static because we're going to put a VIP in front of it, and we want to be able to load balance to an application. We don't want that IP address to change for that application under any circumstance. So elastic IPs make much more sense. This is just going to be used for me to manage FortiOS, so the fact that it's using a dynamic public IP should be all right. It also means as the scale out group scales out, that this dynamic IP address can get added very easily. It doesn't have to add an elastic IP for every new FortiGate that gets scaled out. In fact, the other non-master has its own public IP, right? .107 is the last octet here. This one is .231. Yeah, total. Actually, the only thing that's in common is the first octet. Let's go ahead and copy that to the clipboard. Let's paste that, and we'll say that we want to connect with HTTPS : whack, and on port 8443, recall that during the parameters, the deployment process, we said that administration should be on port 8443. And we'll go ahead and pull it up. We get a very normal certificate error, self-signed cert. So we'll proceed past this. And it's going to tell us, okay, well, your username and password is admin and your instance ID. That's true. Admin and I need my instance ID, so I'll come back here and I'll just copy it to the clipboard and then paste it here, and it should ask me to change it, and I will. Yes, so there's my old password, the instance ID. Here's my new password, whatever it is I'm making it. All right. And we'll let that get logged in. We'll look at a couple of other things as that's logging in. Next, on the EC2 console, I want to scroll down to the bottom, and we have auto scaling groups down at the bottom. Now, this I'm going to have to hunt and peck for because I don't do this lab every week, but I'm looking for scale-in protection for that particular target. For the target that is the master 0126, 0126B, 0126B. So let's come back here, and we have the pay-as-you-go auto-scaling group. You'll notice there is a bring your own license auto-scaling group here listed at the top. There's no instances within it, because if you recall, during my deployment process, I said 0. I don't actually want any. And by the way, you can do both. You can have a bring your own license and a pay-as-you-go auto-scaling group. You can have both of them deployed. If you look through our cookbooks, there's examples of that. But I want the pay-as-you-go. And when I choose that on the bottom, let's see if I can scroll this up, see a little bit more. There we go. So I'm choosing pay-as-you-go on the top, and on the bottom, I have some tabs. There's some things in here that I configured earlier, like desired capacity, minimum capacity, maximum capacity, all of those things that we specified earlier. Activity. And this is what I wanted to know a little bit earlier. So launching new instance, launching new instance, launching new instance. There's the first instance that launched. That's my master, 0126B. And we can see the constraints, right? Minimum of 2, maximum of 4, desired 2. Changing the desired capacity from 0 to 2. So this is during the initial deployment. And a second one was deployed right after that. And then a third one was deployed. And it was deployed because of a monitor alarm. Stack main workload, create auto scaling group, high CPU utilization. So yeah, I guess during the deployment process, these two kicked off at 7:39 a.m., which is actually the correct time zone on US Central Time. And then at 7:45, another one kicked off. So there was just more than 5 minutes, I suppose, of average CPU utilization. So it increased capacity from 2 to 3. All right, well, there you go. And then later it terminated. It looks like it took about 10 minutes, and so there we go, low CPU utilization. That's actually unusual for me to see in a lab demo. In this case, I took a break long enough for this to occur automatically. Usually I don't take that long of a break after deployment. But it's early in the morning here, and I had a couple of things to do while we were waiting for the deployment to finish. So very good. And this also tells us where we can go and look at activity history. Wonderful. Now I'm going to go to the instance management. And what I'm going to do is find my master instance. There it is, 0126B. I'll just click a check mark next to it. I'll go to Actions, and I'll set Scale-in Protection. There's a field off to the right side called Protection. It's protected from, there we go. I could scale off and see it. And as you can see, there's nothing listed under either instance. For 0126B, I don't want to scale in to ever remove it, so I'll set Scale-in Protection for it. And it tells me what it's going to do, right? This instance will not be terminated when your auto scaling group scales in. Are you sure you want to protect this? I am sure. Set Scale-in Protection. Wonderful. All right, very good. So I've got scale-in protection to keep the automatic scale-in from happening on that instance. I've got termination protection to keep me from terminating it. I think we feel pretty good about that because it is the master. I think we should be logged in. We are. Let's go ahead and click later over here. So I'm going to go back to that master FortiGate. Now, this is when we talk about master here, this is autoscale master. It is a very similar feature to FortiGate Clustering Protocol config sync. Very similar, not identical feature, not configured the same way, but a very similar feature. If we want to see the configuration commands for it, we'll go config system. Oop, not that. Got a little crazy with my tab key. There it is. Oop, not auto script, auto scale. Auto scale. There we go. Enter. Show. All right. Set status to enable. Set role master. Yep, that's my auto master, my auto scale master. Sync interface port 1. And pre-shared key secret, heartbeat interval. Basically, everybody's checking in with the master. If we go and visit our other FortiGate, and let's go ahead and visit our other FortiGate. I'm going to go back to my EC2 console, go back at my look at my list, my list of my EC2 instances, and get the public IP address of the other FortiGate. Here we are. That's the master. So this is not the master right here. And there's lots of places I could get the public internet IP address in the actual list of columns at the top. But right now, you guys have been seeing me use the bottom half of the screen for a lot of information. There's a lot of information that's available in the top half of the screen as well. For instance, the public IP. I'll just Control C. Control, oh wait, HTTPS colon whack whack. There we go, control. Well, that's not right. I've got a bunch of extra stuff in there. Let's get rid of this. There we go. And port 8443, assuming that that's the correct IP address. That looks like it is. Self-signed certificate error. Admin. Taking an unusually long time to allow me to log in. Did anybody notice that when I brought up the GUI, it did not tell me the default username is admin and the default password is the instance ID? It didn't. And the reason that it didn't is the password is one of the elements that's synced by autoscale. So I just put in the password that I set on the master a couple of minutes ago. It's taking an unusual amount of time. I think I'm going to stop and refresh it just to see what's going on there. Okay, I don't know why that didn't work so easily the first time. Here we go, later. And here's our second FortiGate. If we look at config system autoscale, there we go. It's pointed to the master. Set status enable, set sync interface to port number 1. And the pre-shared key is the one that I typed in earlier. This is all bootstrapped configuration that was bootstrapped in by AWS based on the parameters that I put. Very similar to HA. When I was putting parameters into HA, active passive, it was creating a bootstrap config that would allow, when the VMs booted up, they already had config system HA commands in there. This is very similar in terms of what's happening. All right, so I feel like that looks like it deployed correctly. I have a master. I have someone who's synced with master. Let's go ahead. I don't really need to see the config system autoscale anymore on either one of these. Let's go back over to master. For reference, master is this one, FGT AWS D. The one that starts with D. This is FGT AWS S, and I don't need to know the rest of it. I just gotta remember that D is the master. Let's go ahead and get some configuration in here on the master. We'll say network interfaces. My public side interface should already have an IP address. Actually, I only have a public side interface on this. Here we go. I'd have to add a second interface, a second ENI, similar to what we did in earlier labs. We added a second ENI if we're going to finish out this topology. However, for our example, we're not going to have a group of web servers. We're just going to do a very simple example of this, so I don't think we're going to add a second ENI to it. All right, let's go ahead and put in an alias. This is my public. We can go in and set the IP address is set to DHCP. That's fine. Retrieve default gateway from server is turned on. That should be fine. I don't think there's anything else I need to change in there. Click OK. So before I continue in configuration on the FortiGate, well, the next thing that I'm going to do is go configure a VIP. So I'm going to go to virtual IPs. I'm just going to hit edit for a second. Actually, there's a VIP already. This is bootstrapped in. This VIP is mapped to an address object. The address object is the internal load balancer. So before we continue, let's make sure that that internal load balancer DNS name is correct. So what is occurring here is we have a VIP. The VIP says anything on public port 1, map it to the internal load balancer, but only for port 80, because in our parameters, we set port 80 is what we wanted to be load balancing inside. So, but the internal load balancer is an address object that relates back to a DNS name. The DNS name is this fully qualified domain name, FGT, ASG, dash, and I'm not going to go through the whole thing. It's just way too much. But I need to double check to make sure that really is the correct DNS name. I suppose I probably don't need to. It actually should work just fine, but I'm going to because I want you guys to see where that can be listed. So I'll go back over to this tab. We'll go down to the bottom. We'll go look at load balancers. Keeping in mind, there's two load balancers, a public balancer and an internal load balancer. Assuming my EC2 console starts to respond to me. Oh, let's scroll down there. That's why I couldn't see it. The public load balancer is called front end. The internal load balancer, so this is the public load balancer right here, front end. In fact, let's just kind of scroll this out a little bit. And the internal load balancer, this is the one that's got the name service within it. And this would be a good place to go and double check and look at this and go, all right, FGTASG-C3 alpha 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 820 service ELB. Again, I'm not going to read the entire thing, but let's just do a quick glance. And I'm going to assume if the first half of this is correct, the rest of it's probably fine. In the real world, I'd want to check the whole thing, but I feel pretty confident that it didn't goof it up. So we're just going to check this. Is here. So that I can have both of these up at the same time. Control C, go find Notepad. All right, there it is. And then we'll go back to the FortiGate and see if I can leave both of these up. There we are. FGT ASG-C3 AAA 820-service-ELB-57E 725 6B 9D1 9D1F, pardon me, 9D1F, yes, 5562. Very good. And I am just taking for granted that the rest of this, which is ELB.US East 2, US East 2 is because it's in Ohio, Amazon AWS. I'm just going to assume that that's correct. I feel pretty confident that it is. Really, I'm just running through this so that you can relate what these things do, right? This is a VIP that points to the internal load balancer, and then the internal load balancer would in turn point to the actual application servers. Let's put that back into full screen. So that looks like that VIP was created correctly for me. I could create other VIPs. And it's set to port 80. I feel pretty good about that. Let's go ahead and cancel. That all looks fine. I don't think I want to change any of that. Let's go look at the policy. Make that full screen. The only policy that I see here is the implicit deny policy. Let's go ahead and add another policy. For simplicity, I'm just going to use the single existing interface that's already there. So I'm going to say that this is HTTP policy, inbound policy. I'm going to tell it that I want, if it comes in on public, and it's going to route back out on public. And understanding, ordinarily, I would go ahead and create a second ENI. I'd attach it, and it would connect into private. But for our purposes, this should be fine. I'll go into source of all, destination of the VIP, and service HTTP. Go. Now, as you recall, we do want to source NAT this. Well, actually, I say this. Let me consider that for a moment. If we source NAT this, it will come and yep, we do want to source NAT this. I had to think about it for a second. I had to reason through it. When it gets to the internal load balancer, we want to make sure the source IP address is the FortiGate. Otherwise, the source IP address will be the external load balancer, and traffic will route back through the external load balancer and skip the FortiGate on the return. Same problem that we actually discussed in the HA active lab number 5. So source NATing to be turned on, and I generally always do logging all sessions, but this one I'm not going to leave this turned on because I'm not going to do any testing with this as we go through. What I am going to test is the actual scale out process. I'll terminate one and we'll watch it scale out. Go ahead and click OK. Wait for it to save that. If traffic is going to go into the FortiGate and get accepted on port 80, then there should be a security group on the FortiGate, and that security group should also allow port 80. So real quick, let's just double check. We'll go to our list of instances, and the instances use this security group right here. Fortinet FortiGate stack main workload, a random string in there, FGT ASG security group. Yeah, let's go look at the inbound rules. And I see there is an inbound rule for port 80 already. I don't need to add anything there. If I did need to add it, I could click on the security group. That would take me to the list of security groups. I could then go to the inbound rules tab. I could edit the inbound rules tab. I don't need that. So let's see. Let's just kind of review what we've looked at. We have a security group on the FortiGates that allow port 80 in. We have a VIP that was automatically created, and that VIP resolves to the internal load balancer. We created a firewall policy to accept traffic on that VIP, port 80, send it to the load balancer. That part's configured. We've also, now we didn't do this, the configurational template did this for us. It set autoscale master on the FortiGate master instance, and all of the other FortiGates that scale out will point to that. Very good. Let's go ahead and log into our non-master. Later, please. This is our non-master. Go down into policy and objects. We will go into IPv4 policy. And we'll wait for a moment. There's my inbound policy. And you'll notice my inbound policy uses the VIP. It's exactly like I created it on the master FortiGate. And that's just auto scale, the config synchronization functionality doing its job. Kind of bizarre that I got logged out there. Let's try that again. Later. If I go into network and interfaces, we also see that I added an alias to port number 1. It's kind of interesting. It looks like the CloudFormation template deployed 2 interfaces to this FortiGate, but only deployed a single interface to the other FortiGate network interfaces. I'm going to go check that out actually in just a moment. I'm curious if something failed in the CloudFormation template process or didn't complete because I don't see a second ENI here. That's kind of interesting. So this other FortiGate has both ENIs. And as you can see, the public alias did get synced. So this looks to me like something within the AWS CloudFormation template process didn't complete correctly. And in a couple of moments, I'll actually troubleshoot that. I'll take a look and see if I can figure out what happened there, or at least figure out if it created the ENI and failed to attach it. And then maybe we can figure out where we can trace that process down. So let's do this. We're going to do a little bit of testing first, since I've got these. If I was really wanting to test this out really well, I'd create pools of web servers. I would make the web servers the target of the internal load balancer. But we're just really focusing on the auto scale functionality. So I just really want to see the scale out and the scale in. What I'm going to do is go to the scale out groups in the EC2 console, rather than trying to create load on my FortiGate, which would be really difficult to do. What's really easy for me to do is to go to the scale out groups, find my pay-as-you-go group, and go to the scaling policies and execute a scale out. So I'm manually doing a scale out. So let's just take my pay-as-you-go auto scale. Let's see, this should be under, they've changed the GUI here. The old auto scaling group console is no longer available. Yes, you guys have made a little change here. I see that. What I'm looking for, we've got activity. I wonder if it's listed here now. Automatic scaling, scaling policies, actions, 2 policies. I'm looking, let's see, scaling group, pay as you go on high CPU utilization, on low CPU utilization. This used to look just a little bit differently, but this looks like my scale out policy. It says pay as you grow on high CPU utilization, shrink on low CPU utilization. Indeed, I'm pretty sure that this is what used to be called my auto scale out policy on the left, and this is what used to be called my auto scale in policy on the right. So let's go ahead and check the box on this and assume it is. I feel fairly confident that it is. Also, when we looked at activity a little bit earlier, this is what executed and automatically scaled out. So I'll go in here, I'll check this, and I'll say actions, and I'll say execute. So this has changed a little bit. If you've seen earlier versions of this, maybe the format, this used to be a list, not these big boxy objects. There used to be a list here. And you would check things in the list, and the names of the policies were just a little bit different than they are today. But the same basic thing would happen. You would choose a policy, and you would execute that policy. So if I go down here and I choose it, and I choose execute, are you sure you want to execute this resource? I am sure. Scaling policy was executed successfully. And if we look on the top half of the screen, it's currently set to instances 2. Wonder if we refresh it, if we can say instances 3. There we go, instances 3, which means I should be able to go back to my instance list and there'll be an instance that's deploying. It's going to take a couple of minutes for it to deploy. Even with all of the configuration bootstrapped and everything ready to go, getting through these status checks will take a couple of minutes. I'll go ahead and pull up the public IP. So let's copy, this is my new instance. We'll go HTTPS : whack whack. The config has to bootstrap. It's got to come up, synchronize with the master. Oh, I forgot to put in port 8443 there. There we go. Yeah, it's not ready to come up yet. That's not altogether shocking to me. I'm trying to get there really fast. So we'll give it a minute. I can also go down and look at my auto scaling group. It'll probably already say successful since we're buying a little bit of time here while we wait for that instance to be available. Auto scaling groups. And there we are. There's the pay as you go auto scaling group. The desired capacity now says 3 because I scaled it out. Activity probably says there was a successful launching a new EC2 instance. When did that happen? That's still, it looks like, in the process of happening. The last thing that actually completed was the scale in. So it does not say successful yet. It's a status mid-life cycle action. It's in the middle of doing it. So I'll just hit refresh here and we'll wait. Well, in the interest of utilizing some time, I'm going to go ahead and pause the video. I'm going to leave the screen right here. Let me refresh it one more time. Still in the mid-life cycle action. Okay, I'm going to pause the video. It's 8:29 a.m. and when we resume the video, we'll see how long it took to actually finish executing this. So be right back, everybody. Well, here we are back from break. And it was 8:29, almost 8:30, when I decided to go ahead and pause the video. At that point, it had been at least 45 seconds or a minute. So it was about a total of 2.5 minutes since I paused the video, just approximately 2.5 minutes. And we now see successful. And if we look there, actually, we can see exactly how long it took. It started at 8:27 and 18 seconds, and it took about 3 or 4 total minutes to actually come and show a successful health check. So if we go up into the top right-hand corner, we've got that link to the public IP address that I pulled earlier. I pulled it from the instance list, and I'm going to go ahead and refresh it because I don't know how long that's been sitting there at that certificate error. All right, we'll say advanced, proceed. Should be able to, if config synchronization has happened, I should be able to log on with the same password that I set on master. Looks like that's attempting to occur. While that's attempting to occur, I'm going to go back to that list of instances over here. Yep, there it is. It's funny, it still says that it's initializing. Let me refresh that. Nope, still says that it's initializing, although it's certainly responding. Try it again. Refresh. I'm just refreshing the login page and putting my login credentials. There we go. This might be a 623 thing. I've noticed that this was something I saw on even some on-prem 623 devices, odd behavior with the login prompt, although honestly, I thought it was just me with my home FortiGate kind of goofing around, but it looks like there might be something to that. I did notice on 625 that that behavior never seemed to occur, so I wonder. I think as config is syncing, I think it's logging me out. All right, very good. Later, and let's see how we did. Let's go into network and interfaces. Now, I still haven't gone back and put any troubleshooting into why the master only has a single network interface. I'm going to have to figure that out. But I do see there are two network interfaces on this, and the alias for public synced, which makes me suspect that if I look at policy, that the firewall policy also synced. HTTP inbound policy, yep, that's synced as well. It's there, so scaling out worked, and it worked correctly. And I could go execute scale in now. In fact, let's go execute scale in. I don't want to put that third FortiGate for any real amount of time. Let's go auto scaling groups. By the way, if I waited long enough, it would certainly scale in on its own because my CPU utilization is so low. It would take about 5 minutes total, and might be pretty close to that now. The pay-as-you-go auto scale group, the second one, check that. Activity, let's just look at the activity history. The last thing that executed was, it says a user request. So this was not a monitor alarm. A monitor alarm looks like this. It says a monitor alarm kicked off this policy. No, this was a user request. I did it manually. So let's go to my automatic scaling, which I believe used to be called scaling policies. And we'll go into my shrink on low CPU utilization. There should be a checkbox. There it is, checkbox next to it. Actions, execute, and it'll scale back in. Now, it won't scale in master, so that should not get scaled in. Let's go to our list of instances. Hasn't started to scale in yet. Here we go. So just to look backwards at this, I have, at the moment, it hasn't scaled in yet. I've got 3 total instances. 2 instances are in AZA, 1 instance is in AZB. If I execute it again, I probably would put another one into B. It started off with a single instance in A and a single instance in B, but since it only has 2 AZs to work with, eventually it was lopsided. If I execute it again, it should have been in B. Let's just refresh here. There we go. The second one in A is what's shutting down. So my scale in policy is executing and this one is disappearing. Well, now that we've got that working, let's go take a look at FortiGate Master for a second, because things don't look quite right to me about it. This is, by the way, this is not something that I've set up to fail. This is just a genuine head scratching. It doesn't look like something executed correctly when we deployed the CloudFormation template. I see one network interface, ETH0, which is ENI ED5D, right? And it plugs into public subnet number 1, 10.0.0. Let's go look at our list of network interfaces. Instance NIC2, let's see, this would have been in AZA. So all we need to do, let's sort by zone. And in zone A, there are a total of 4 interfaces at the moment. There are 2 interfaces that are for load balancers. I see the description, ELB network, so those don't look to me like they're related to an EC2 instance. They look like they are related to an elastic load balancer. And if we look down the list here, also in A, VPC endpoint interface. This is probably 10.0.0204, elastic interface attachment, endpoint service. This is going to be related to some other service, possibly S3, DynamoDB. There is a service endpoint, so that's also not an EC2 instance. And this is A10.0.0.20. So I don't see a private side interface for the master FortiGate. This is the public interface for the master FortiGate. In fact, let's call it master FortiGate public interface. Just label these, make it really easy. This is a service endpoint. So some other service, probably the S3 or the DynamoDB, has got an internal ENI inside the VPC. And this is an elastic load balancer. If I look down here, 10.0.0.186, it's got a public IP address on it. It's definitely the front end load balancer. So there's two interfaces on the front end, load balancer and load balancer. Also a front, this is the internal, this is the service, this is the internal load balancer. It only has a private IP. So this is internal load balancer. Yeah, so what I'll do is front end load balancer, we'll just put a little deal there. It says public 1 subnet. Just makes it a little bit easier to read. Service endpoint, and that service endpoint was in the public subnet. It's probably where it's bootstrapping configuration. Here we go. Now let's go through our other list here. Again, we have elastic load balancers, but these are in a availability zone B, right? US2B, US2B. So let's see what we have here. We have an elastic load balancer. This is the front end load balancer. I can see it right there. I can see that it has a public IP address. That's definitely front end load balancer for public subnet 2. Front end load balancer, public 2 subnet. This is the service load balancer, or what is called the internal load balancer, which they named service. So internal load balancer, private to subnet. And this belongs to a FortiGate, 10.0.2.144. And this belongs to a FortiGate, 10.0.2.110. Just a second here. Let me go back to this. 10.0.2.144, 10.0.2.110. Let me just take a look at the instance IDs. So there's no instance ID for this one, but there is an instance ID for that one. Just make sure that this is, no, this is a service endpoint. So this is not for a FortiGate. Apologies. Service endpoint, public 2 subnet. And down here, that's our actual non-master FortiGate. 10.0.2.110, I see an instance ID, A33, and let's look at that public IP, 128.107, which is that FortiGate right there. Yep, that's our non-master FortiGate. So we'll say, I'm just gonna call it non-master. It doesn't really have a name per se that I've been calling it, so non-master public 2 subnet, public 2 interface. Which (10.0.3), also with instance A33. So if this is the non-master FortiGate with instance A33, this is also the non-master FortiGate instance A33. It's got this really nice complex name. I'm not going to say non-master private to interface. So when I'm thinking about what seems to have fallen apart here, it's not that the CloudFormation template created an ENI for the master in the private network and failed to attach it, because that was certainly one possibility, that it created the ENI and it didn't attach it. It did not create the ENI at all. So what I'm going to do is go back through my CloudFormation. I will click on my stack. Yeah, you say create. Let's look at nested auto scaling group, lambdas, auto scale handler, create NIC attachment for service. Service provider, script, EC2, network interface, attachment service. So it looks like those service endpoints that I was pointing at earlier, those are actually for Lambdas. They're not for an S3 bucket. They're for the Lambdas to be able to execute within the network. That's what those look like. There's my Dynamo database, my load balancing components, stack main workload. I'm just going to go to the main stack. Let's not say nested. Create new VPC, create main workload. Resources, created security group. Security group, VPC endpoint, created a role, so it had access rights, instance profile. I do wonder about that. We might have to go visit that. And then it created a bunch of other CloudFormation templates. This is going to undoubtedly take me a couple of minutes to dig through. So what I'm going to do, rather than making you watch me go through screen by screen and think out loud, I'm going to go digging through this, and then I will come back and let you know what I find. So give me a few minutes. Give me a few minutes. I'm going to pause the video. Take as many minutes as you like. Pause your video, and I'm going to unpause when I think I've found out what happened here. I'll be back. Well, welcome back. Let me just straighten my microphone here for a second. There we go. Welcome back. So I went digging through the CloudFormation template. I found the nested template within it that has an event called a NIC attachment. And I went looking through that. It just executes a Lambda that's supposed to attach a NIC. When I look at the outputs of that, I see that there's this service script that happens in here. And as I dug through this a little bit, I found that it's supposed to log the NIC that it attaches into a Dynamo database table, and there should be a field in that table. So I thought that was kind of interesting, and I went and I looked at the Dynamo database table. I'll go back over here. So I went to the Dynamo database, I went to tables, I went to the list of the tables, I found NIC attachment, and what I found was there is only one listing here. This ENI B60 was attached to this instance A33. And just to kind of go back to what that means is that that's the non-master private to interface. I believe I should have seen a second event that was logged in the Dynamo database table. Don't see it there. Little bit of pulling the curtain back. This is 2.0.8. I don't use 2.0.8 very much. The version of the deployment template. What I'm going to do is I'm going to pause the video. I'm going to delete everything that I did. I'm going to redeploy, see if it does the same way twice. If it is repeatable, I'm then going to go try it on 2.0.7 because I think this might be something in 2.0.8, which is a relatively new version of the template. Maybe some combination of circumstances here that lead to this. So first, I'm going to see if it's recreatable or I hate to say it's just one of those things, but it's a non-recreatable issue. Let's just see if I delete and redeploy again if it happens the same way. So I'm going to pause the video. I'm going to delete everything. Actually, you guys can watch me do the delete. So first, let's go ahead and turn off our. let's go back to here. We'll go to the EC2 instance list. We'll go to the auto scaling groups. I'm going to turn off the scale-in protection. Don't know for certain that I have to turn off the scale-in protection before I try to delete everything, but just in case it stops or pauses the delete process, let's go ahead and get rid of that. So I'm going to the pay-as-you-go auto scale group. I'm going to instance management. I'm going to the master instance 126B. I'm going to choose actions, remove scale-in protection. Yes, remove it. I'm also going to remove my termination protection. So I'm going to go back up to EC2 instance list. There we go. And I'm going to go to the master instance, this one, right click, instance settings, change, termination protection. Disable it. I want to be able to terminate this. Then I will go back to my CloudFormation template, my list of my stacks. I was actually just on the screen just a second ago because I was looking through it. We'll go list of stacks. I'm going to turn off the nested view. I just want to see the main stack that I kicked off, that kicked off all of the other substacks or child stacks, if you will. So I'm going to choose that, and I'm going to say delete. And that's supposed to roll back and delete all resources implemented by the stack. That takes a few minutes. I would say it takes as many minutes as it took to create it. So, something like 5 to 10 minutes to get through that process. Now, ordinarily, after it went through that 5 to 10 minutes, I would then still go and double check. I'd look through my VPCs, I'd look through my EC2 console, I'd look through my auto scale groups, my load balancers. I would just double check and make sure that it really did delete everything. I would love to tell you that it always does everything it's supposed to do, but we're troubleshooting a problem where it didn't create something that we thought it was supposed to create. So I never take anything for granted, especially when it could cost me money. So I would still go through and make sure everything that was deleted. I'm not going to do that in real time right now. I'm going to pause the video for you guys. When I come back, I will have redeployed the 2.0.8 templates again, and we'll see if it did the same thing. So be back in what for you should be a split second. Talk to everybody soon. Well, folks, I'm just resuming the recording to let you know that I've deleted the last stack, and the deletion process took effect. I'd say it took me about 10 minutes or something to finish the delete. And I kicked it back off again. Once again, I'm trying 2.0.8. I'm not even downloading the zip file again. I'm just using the existing stack of deployment files that I put in my S3 bucket. It's 9:11 a.m. roughly, and I've just executed that. So I'll pause again in about 8 or 10 minutes. I'll unpause and we'll go see what it did. Talk to you soon, everybody. Well, everyone, welcome back. My deployment completed, at least in so much as all of the nested stacks say create complete. However, I have experienced something kind of interesting. When I go and I look at the nested stack template for create NIC attachment service, and I scroll over on the right side and I look at events, it doesn't actually, there are several items in here that say create complete. I see it was initiated, and then I see a couple seconds later it was created, completed. I see that several different times for what looks like maybe creating the NIC and attaching the NIC. When I go into the Dynamo database and I look at the NIC attachment, I refresh. Now you'll recall from earlier in the video, what should have been nearly instantaneous for you guys, I only had one of my FortiGates listed here for an instance ID. And this time I have 0 of my FortiGates. So not only was I able to recreate the problem, but I actually recreated it a little more strongly. Neither of my FortiGates seem to have had a private NIC attached to them. And I could go and verify that by looking at the Elastic network interfaces. I suppose I should show you the two EC2 instances first. Let's do that. Let's look at EC2 instance list. A little bit easier to understand what we have going on. As you can see, the earlier created instances are still in the list. They're terminated, and I have two running instances. These are the ones that I created more recently. In their resource names, they have 84F80E70, so they're really easy. They're really easy to identify. They're the only two that are running, so that makes them really easy to identify. So we have one over here in availability zone B. We have one over here in availability zone A. The instance IDs are 31A, just the last three digits, and 090. Let's remember those numbers, 31A, 090. Now let's go down to Elastic Network Interfaces. And there's this great little field that I forgot about earlier. We can scroll over to the right side and we see instance IDs. So I could go back through and label all of these for their given purposes, whether they're for a load balancer. Obviously, they've got a little description over there, or it's a VPC service endpoint. But this is really what's going to help me out here. There are two interfaces that are attached to instances. And we have one on instance 31A, one on instance 090. If we look down at the bottom, they both plug into the public subnets. And I could verify that a couple of different ways based on the CIDR 10.0.0 and then the CIDR of this one, 10.0.2. Those are both my public CIDRs. The fact that they have public IP addresses associated with them, or if that wasn't enough for me, I could actually go look at the name of the subnet that they're plugged into, and it would be the public subnet within each availability zone. So public subnet 1, public subnet 2. But I'm satisfied. Those are the only two ENIs on my EC2 instances. Everything else here has some other purpose, a load balancer, either a front-end load balancer with the public IP addresses or the internal load balancer, or a service endpoint that allows connectivity to Lambdas or something along those lines. So 208 did it again, and it did it worse because this time both of them were affected. Now, I thought perhaps I just needed to wait a little bit longer and those would get created. So I actually have waited several minutes and it didn't create. So I'm going to now roll that stack back. I had to turn on any type of endpoint or EC2 protection, so I don't have anything set from scale in. I don't have anything set from protecting it from terminate. So I can just go right into CloudFormation, turn off the nested view to make it a little bit easier to read. There it is. Find this, delete it, and delete it. And I'm going to go try 2.0.7 because I've used it many times before, whereas 2.0.8, I don't think I've used it in any of my courses. I think at this point, every time I've used it has been for these the recordings that I've been working on. So I'm curious if 2.0.7 works as flawlessly as I remember, in which case there is some type of issue with the 2.0.8 templates. I'm going to put the recording on pause, give this a little time to delete. I'm also going to redeploy. The steps will be the same. I will simply be downloading a new zip file, and all of the other steps that I showed you are going to be identical. I'm going to stop the recording or pause the recording, and we'll be back in a little bit. Well, folks, welcome back to my recording. I just want to review real quick what I did differently in this deployment. First of all, I went to the same URL that I gave you a little bit earlier. I went to github.com/Fortinet/FortiGate/Autoscale/releases, which I'll just go to the main page there. And rather than using the 2.0.8 release, which released this summer, I used the 2.0.7 release, which released late last spring, late April. Once I got there, I used the same named file, the FortiGate Autoscale AWS CloudFormation zip file within the 2.0.7 release. And from there, the steps were the same. I downloaded the zip file, unzipped it, uploaded it into my S3 bucket. I did empty my old S3 bucket so that I made sure that I had a completely new set of files. So in my S3 bucket, there's still a single folder called deployment package, and then within that folder is the unzipped contents. I then kicked off my CloudFormation template, And once again, it kicks off a main template and a bunch of nested templates underneath it. And if we go looking, I'll just do a quick refresh here, make sure we really are looking at yep, we're looking at all the latest data. And I see a bunch of create completes down there. But let's get to the really interesting things. So when I go looking at network interfaces, well, okay, let's first go to instances, and then we'll go look at network interfaces. Lots of ways we can do this. And as you can see, my old terminated resources still show up as terminated. But here we go. My new resources, I've got one in availability zone A, one in availability zone B. It ends in 659 and 6 echo 0. If I click on them, I can actually tell you just by looking at this. I see two NICs, ETH0 and ETH1. So ETH0 in the public subnet, 10.0.0, ETH1 in the private subnet, 10.0.1. And if we look at the other instance, we'll see the same thing, but for the second availability zone, ETH0 in 10.0.2, ETH1 in 10.0.3. And another way that I could go and verify the same thing was to go to network interfaces to make sure I can see the field on the right side that says instance ID, and then I can sort by that field, instance ID. Come here, let's go all the way to the right. Here we go, instance ID. So I see there are two elastic network interfaces for 6E0 and two elastic network interfaces for 659. And look at this, additional NIC. This is in the 207 release. When it created that second NIC, it actually gave this additional NIC for this instance. And the additional NICs, indeed, they plug into the private subnet for each respective instance. So if this network interface plugs into the public subnet, this network interface plugs into the private subnet, this network interface plugs into the public subnet, this network interface plugs into the private subnet, or vice versa, one of them. Sorry, that one's in the private, that one's in the public. So the ones that have the additional description on them plug into the private. So for instance, that's got the additional description, and if I scroll down, it plugs into 10.0.1. And that's got the additional description, and we look at it, it plugs into 10.0.3, whereas 10.0.1 and 10.0.3 are both private subnets. So there you go. I think we found a little problem in that 2.0.8 release. Outside of the scope of this video, I'm going to go and report an issue and put in a description for it. And hopefully they can resolve that. I was able to recreate that twice. I am using the Ohio region. I do wonder if maybe I made adjustments to some of the timeouts, if that would work a little bit better or differently. But with certainty, 2.0.7 works quite well. And so I'm a little bit curious about that 2.0.8 release. I hope this helps you. The remaining videos for this course will be about Microsoft Azure. So there'll be 5 labs in Microsoft Azure, similar to some of the labs that we did in AWS. I look forward to meeting you in person sometime. If you ever run into me at some type of event or some type of class, please come by, say hello, tell me that you saw the public cloud videos. Let me know how you think these videos went. I can always do a better job. Thanks very much for attending. Have a nice day, and I'll see you in some other video or some other class sometime. Bye-bye. Before I leave, I am going to remind you to delete all of your resources if you've done any of these labs along with me. And just to be complete there, I'm going to go ahead and kick off the deletion of the CloudFormation template. You guys have seen me do this a couple of times. Afterwards, I mentioned after I delete the CloudFormation template and I let it roll back all the resources, I like to go manually check to make sure things get deleted, because there were 1 or 2 resources like the S3 bucket that were not part of this CloudFormation template. So I'm going to kick off the delete the stack. That's going to take several minutes. And after it's done, I'll unpause the video and I'll walk you through checking a few other places, making sure things were deleted. So for those of you who are doing the lab, make sure you just pause your video for a couple minutes, go get a cup of coffee, come back, and in a few seconds, for you, what will be a few seconds, I will walk you through deleting the rest of those resources. See you soon. Well, we are back on the line. Our CloudFormation template has finished deleting and should have rolled back all of the resources that were created as part of the template. So let's go check those first. We'll go into EC2 and look at EC2 instances. Yeah, so I don't have any running instances. I have my existing key pair that I had before. If I go looking down at auto scale groups, and I wait, yep, no auto scaling groups. If I look down at load balancers, I'm hoping that both of my internal and front-end load balancer are deleted. Indeed, they look like they're deleted. I suspect my VPC is deleted and all of its subnets, routing tables, internet gateways, everything associated with that is probably deleted as well. We'll just double check. Yep, I see 0 VPCs and all of the things that would have existed in my VPC are all gone as well. So really what this is going to leave me with is the S3 bucket. I need to delete that S3 bucket. It's not consuming very much, but it is consuming just a little bit, so let's go ahead and get rid of it. This is the one that I actually deleted yesterday. It's interesting that I've had this happen a couple of times to me where it shows up under this screen and it says region error and I can't delete it. It appears to be gone. And then other times it doesn't show up. I'm going to assume this is something wrong with the AWS console. I don't believe that's actually there, but this one is definitely there. This is the bucket that I created today for this course, 10th of September 2020. And there we go. You cannot delete a bucket if that bucket has contents. You have to empty the bucket first. So what I'm going to do is attempt to delete this folder. Let's just say delete it. Now the folders, now the bucket is empty. So let's see if we can, yeah, I gotta go to the main list to delete the bucket. I'm clicked on the bucket right now, so we'll go back to the main list. There it is. And we'll say delete. It wants to make sure that I don't delete this thing on accident, so it's gonna make me type in the full bucket name to confirm that I want to delete it. And since I'm lazy, I'm just gonna copy and paste its name. All right, successfully deleted this bucket. Just kind of curious if I switch to the previous console experience, if that erroneous bucket, well, it's still listed in there. Autoscale 99. Well, I'll probably follow up on this. Type the name of the bucket, confirm deletion, and actually we'll copy bucket ARN over there, delete. This is gonna have some extra bits in it that I'm gonna have to delete. There we go, delete all that. There we go, FortiGate Autoscale Lab6 992020-R Aslan confirm. No extra. Yeah, it's not letting me delete it, but I don't think that bucket really exists anymore. So I will probably follow up on that in 24 hours, see if it eventually disappears off my list. All right, very good. That is the last of the AWS steps, just going through and making sure everything is deleted. I also like to watch my bill in the day after lab. It takes about 24 hours after you create resources for it to show up on the billing page. But if you go into services and you search for billing, come in here and see what your current bill is looking like, your month-to-date services. Yeah, currently at $15. There you go. So if I come in tomorrow and the days follow and this number is continuing to grow, then I might be concerned. You'll see that it's forecasted at $34 this month. However, that would assume that I continue to use resources like I've been using them the rest of this week. And I won't, so I shouldn't end up with a $34 bill. All right, very good. I'm closing out of AWS. I will see you all in the Microsoft Azure videos. Thanks a lot. Have a great day, everybody.